There is a convention that's adopted by IUPAC to name organic compounds. So before we go to the details, I want to tell you some aspect of important aspects that you encounter when you are naming. That is substituents. If you have a chain, something like this with carbons, all these are carbons, you have branched different kind of substituents on the chain. So those substituents are also derived from, obviously, from a neutral molecule. For example, if you just look at here, this is methane, which is CH4. This is a neutral molecule. But as a substituent, this is methane, okay? But as a substituent, when it serves as a substituent, for example, attached to this, it will lose one of its hydrogens so that it can make a bond through that CH3. Therefore, that as a substituent is called not methane, it is methyl. Next to that, if you have ethane, which is a neutral molecule, it's a standalone molecule by itself, but if you just remove one of the hydrogens, you would have CH3, CH2, and through this carbon, there is an attachment to another chain. So it serves as a substituent, and it's called ethyl substituent. So this is methyl substituent. So for example, if you have CH3 here, that's methyl substituent. It's bonded through that carbon to this carbon. So when a substituent is ethyl, you have CH3, CH2, so it is an ethyl substituent. That means you have CH3, CH2, and the carbon here. So it's named ethyl. You don't call it ethane as a substituent. As a substituent, it is ethyl group. Similarly, you have a propane. This is propane, derived from propane, or it's a propane. There are two possibilities to act as a substituent. Like the substituent itself can be straight chain. You can just attach it through this carbon, CH3, CH2, and remove one of the hydrogens, and you are just attaching it to that. For example, 3 carbon is like this, 1 to 3 carbon. So you are attaching it right there. You are attaching it right there. So if you just attach directly the chain, it's called propyl. It's a normal propyl. But if you have a possibility where you can attach through this carbon, remove one of the hydrogens, like this, one hydrogen is removed, so it would be attached through this carbon, while you keep still CH3. This is called isopropyl. So it is a branched kind of substituent. So it is like this. Like this. So you are substituting it right there on the chain. So that is isopropyl. So for propane type or 3 carbons, you can have 2 kind of substituents. One is normal propyl, just straight chain, or you can have an isopropyl. The next one is butane, a neutral molecule. Butane is with 4 carbons, as you know. You can attach on your main chain as a straight chain, 1, 2, 3, 4 carbons through this carbon right there, or one of the carbons at the extreme end. So this is attaching through this. That is just a butyl substituent. So this is normal, a straight chain. We call it N-butyl. But for this, you can also attach it, for example, through one of the carbons, this carbon, but you make, this is CH3, this is CH3, this is CH3. As you see, all are 4 carbon. The 4 carbon has this possibility as well to branch out. So you have a central carbon where you have 3 carbons around it with CH3. That's how we branched it. So this is actually now is a tertiary because it's attached to 3 carbons. So a tert butyl is tertiary butyl group. That means all branched, and you are just attaching it through one of the carbons as the center, and 3 of the carbons are containing CH3 group. So metal, 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 1 is carbon. So what we have done is, if you just keep this carbon and remove 2 of the hydrogens and add 1 hydrogen to this one, you have CH3, and keep this CH3, through that carbon you can attach a tert butyl group. And there is also another possibility where you can attach, you can just put 1 of the CH3s on this carbon and remove 1 of the hydrogens only. You have CH3, CH, CH3, CH2. So this is called isobutyl. Isobutyl is just one of the possibilities where you have CH3, CH3, and you have a CH right there, and you have a CH2. So you are attaching it through this. So isopropyl looks like this, isobutyl looks like this. So it is very important, before we go to in detail the nomenclature of organic compounds, you need to be familiar with some of the substituents. The substituents are important for you to name a compound. So there is a metal substituent, which is very easy, CH3. An ethyl substituent is a 2-carbon substituent. It is CH3CH2, and the bonding happens through this. When I show here, that's where the attachment happens. And for propane type, you have 2 kind of substituents that can be generated. Propyl is directly a straight chain, while isopropyl is a branched one, like this one right here. This is CH3, this is CH3, don't forget this is CH, and you are attaching it through that carbon. For butane, for example, you'd have about 4 of them. I haven't put here one of the sec butyl as well, where it could be CH3, CH2, say that is CH2, and you have this is CH2, and you have CH3, that's 1, 2, 3, 4. You have this is attached through that. So that is just directly attached to this, which is almost okay. So this is sec butyl as well. This is called sec butyl. So what we have done is, instead of CH having another CH3, we have C is attached to carbon, and the attachment is through this carbon. So there is 1, 2, 3, 4, still 4 carbons, but the branching happens on the second carbon. That's also called sec butyl. So these are some of the substituents that you mostly encounter in naming organic alkanes, and we'll do some more examples, practical examples, in naming an alkane or hydrocarbons that are different chain lengths. Let's apply some of the rules for this organic compounds. On the board I have 1, 2, 5 different compounds, and we'll be practicing on this 5 different compounds and apply the IUPAC nomenclature. So if you just look at compound 1, in compound 1, the first thing we have to do according to the IUPAC convention is to find the longest chain, the carbon chain. What does that mean? If you just count a carbon chain, this is 1, 2, 3, 4. If you just go that way, that is 4 carbons. So we have to make sure that what is the longest chain we can have. 1, 2, 3, 4, 5, 6, if you just go this way. And if you just go straight all throughout that, 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain actually is this. The longest chain is this is the longest chain. The rest are substituents. So it is an 8-carbon compound. The 8-carbon compound, the base would be octane. So we start with just a long chain called octane. Octane. But now we want to know what position and what substituents we have. In this case, in this substituents, if you start from here, 1, 2, 3, at 3 position, at carbon number 3, I have a metal group. But in the second rule, you should always start from the side where your substituents would have the lowest number. So I would start counting rather than from this end. I would start from the one which gives me the lowest number. So at position 2, I have a substituent. Therefore, that takes precedent, and the counting actually starts from this side. 1, 2, carbon number 3, 4, 5, 6, 7, 8. All right? So make sure that you are counting from the side where you get your first substituent to have the lowest number or numbering in the carbon sequence. So I would be starting from the left side by saying at 2 metal, at 2 position I have metal, 3, 4, at 5 position I have ethyl, and at 6 position I have metal. So this compound would be named, remember another rule would be, you should always start with alphabetical order for the substituents. So between ethyl and metal, ethyl would take a priority. So where is my ethyl? It is at 5 position because it is 2 carbon. So I would start by saying 5 ethyl, ethyl, okay, 5 ethyl. Next would be the next lowest number at 2 metal, 2, 6, since both are metals, you should be familiar by just condensing them to say dimethyl. There are 2 metals, so we call them a 2,6 dimethyl octane. So this would be called 5-ethyl 2,6 dimethyl. At 2 and 6 I have 2. If I have 3 of them, you say tri, and so on. Okay, so this compound is named as 5-ethyl 2,6 dimethyl octane. So octane being the longest chain. Okay, now let's go to compound 2. In compound 2, the chain obviously looks like all this, but make sure that this is 1, 2, 3, 4, 5. The longest chain would be this chain. Not, for example, if you start from here, 1, 2, 3, 4, 5. They are equal now. So remember, you have 1, 2, 3, 4, 5. When they are equal, remember, this is another rule. When the chain is of equal lengths, when you count, you have to go with the one which gives you the more substituents. That's another rule. So if I go through this, I would have how many substituents? I would have 1, this is 1 substituent, This is another substituent. There are two substituents on this. And if I go through this, it will also have two substituents. So let's just look at what the differences would be. If you just go through this directly, you have 1, 2, 3, 4, 5 carbon, which is pentane. Remember, this base is pentane now because 5 carbon. At 2 position, I have 1 metal, and at 3 position, I have another metal group. So this is a 2,3 dimethyl pentane compound. 2,3 dimethyl pentane. So this is by just going through this chain 1, 2, 3, 4, 5. How about if I go the way we have outlined earlier, 1, 2, 3, 4, 5, starting from this. So if you go to 1, 2, 3, through that chain, it gives you the same 2,3 dimethyl pentane. So it doesn't really matter if you just go through this chain or this straight chain. So those would give you similar names. So the compound is 2,3 dimethyl pentane. So there are rules that we have outlined already. So as a review, I would say first find the longest carbon chain. Second, count from the side where you would have the lowest number in substituent position. That means in this example, for example, if I count from this side, I would have 1, 2, at 3 position is my metal group. Rather, what you have to do is the first substituent would be at 2 positions than at 3 position. Therefore, start counting from the side where your substituent would have the lowest position in carbon number. And make sure that you also write down with alphabetical order for your substituents. Your substituents, for example, in this case, ethyl, the 5-ethyl becomes first E versus dimethyl, the methyl group. So it doesn't go with di, remember, it goes with methyl. M is what is counts for the alphabet, not the di, the tri, bi, those are not considered in the alphabet also. All right, let's see this chain as well. So if you look at this chain right here in this compound, I would count 1, 2, 3, 4, 5, 6, 7, 8. This is an octane compound. If this, I would say, is octane, definitely it looks like that's the most priority, or that's the chain I would get. Because if I count from here, for example, 1, 2, 3, 4, 5, 6, 7, that's heptane. No. So if I count from here, obviously it is shorter. 1, 2, 3, 4, 5, 6. So the count should start from here. 1, 2, 3, 4, 5, 6, 7, 8. Now my substituents would be, this is my substituent in that chain, this is another substituent, and this is another substituent, and metal substituent, ethyl substituent, metal substituent, 1 carbon. So remember what we said about substituents. It's attached directly on the longest chain. So now you wouldn't start counting from here, 1, 2, 3, 4, because your substituent becomes, the first substituent would be at 1, 2, 3, 4, 5. No, because I have a possibility where my substituent would start at 3. 1, 2, 3. So I start counting from the one which gives me my first substituent. My first substituent would have a lowest number. So instead of 1, 2, 3, 4, 5 at this position, starting 5-ethyl, I have a possibility where I could start 1, 2, 3 position. So it would be a 3-metal starting point. So carbon number 3. At carbon 4, I have 2 substituents, and then the chain. So that's simplified. So now at 4th position I have ethyl. So I should start with ethyl substituent, because this is metal substituent, this is metal substituent. E versus M, alphabetically E comes first. So what I would have would be 4 ethyl, 4 metal, again, because at same position I have metal, and 3, actually I would have a 3-4 metal, dimethyl. Therefore, since they are the same in terms of as a substituent name, I could just name them as 3,4 dimethyl octane. So that would be octane. Sorry for the crowded space. So this is 4 ethyl, 3,4 dimethyl octane. Yes. All right. So that's how we go about naming. I hope so far you are following clearly. In the next compound, this compound, let's see the chain. The chain, if it starts from here, for example, 1, 2, 3, 4, 5, 6, 7 carbon. Okay. Starting from here, straight 1, 2, 3, 4, 5, 6, 7, 8. No. Therefore, I have an 8th carbon compound here. 1, 2, 3, 4, 5, 6. So the longest chain is the one in the middle, because you have 1 carbon here, 2 carbon, 3 carbon, 4 carbon, 5, 6, 7, 8. So it's still an octane compound. Octane with 8 carbon. So now if there are only 2 substituents, then 4. If you have this chain, this is a substituent, this is a substituent. The substituents are 2 of them. At position, you don't start from here, because it would place your substituent at higher number. 1, 2, 3, 4 versus 1, 2, 3, 4. Actually, both are at 3rd position in terms of the position you have. Therefore, I would go with the alphabetical order. Therefore, I would start actually from here, because this is already is what becomes first. So it would be 4 ethyl, 5 methyl octane. What did I do? I started from this side, because both are the same. 1, 2, 3 at 4th position, if you count from this side. And if you count from this side as well, it's 3rd position. So I give the priority based on the alphabetical order for E. So that's another detail now added to this also. 4 ethyl, 5 methyl octane. So once you know all the rules, naming organic compounds, alkanes, is very easy. I want you to enjoy it and make more exercises as you go along. So now let's do our final compound right there. I have this compound. Let me identify what would be the longest chain for this. So this is 4 and 5. 1, 2, 3, 4, 5, 6, 7. If you just go there, it is a heptane compound. If I go straight up to here, for example, 1, 2, 3, 4, 5, 6, 7 as well. Oh, okay. Now it's a little tricky, because starting from here, going through this is 7 carbon. And starting going through this, for example, going through This is 7 carbon, and going straight across is also 7 carbon. So how do you choose between the two routes you have? So the rule is the one which gives you a more substituent would get a priority. So 3 substituents would be, if you go through this, there are 1 substituent here, 2 substituent, 3 substituents on this. All right. So in this case, a 2,3,5 trimethyl, that means you have 1, 2, 3. These are 1, 2, 3, and 4 substituents actually. So this is 4 substituents. 1, 2, 3, 4 substituents. And instead of 4 substituents, you go for 3 substituents. If you just go straight through this chain, this one, you would have 1, 2, 3 substituents. So it is a 2,3,5 trimethyl for propyl compound. So the more substituents you would get would be with if you have 1, 2, 3, 4 substituents. If you just go through that, you have 1, 2, 3, 4. Therefore, 4 versus 3. If you just go through this one, you have only 3 of them. So what we would take would be this route. At 2 position I have metal, and it is an heptane compound. Heptane is 7 carbon. So at 2 position I have metal. This is 2 position. At 3 position I have another metal. At 5 position I have another metal. At 4 position I have propyl group. So there are 4 substituents. So the way I would write would be, on this case, the trimethyl, propyl versus methyl, the alphabet would start with a methyl group because propyl comes next. So it would be a 2,3,5, 2, 3, 5 trimethyl. Remember, when you say di-tri to make an aggregate number of methyl or ethyl group, those are not alphabetically considered. You just consider the M on this case. 2,3,5 trimethyl, and at 4 position, 4 propyl. So you have 4 propyl heptane. This is quite involving because now first you have to identify the carbon chain, the longest chain possible. We end up having 2 of the chain are of same length, because if I go through this chain I get 7. If I go straight to this up to this point, from starting from there, it's also 7 carbons. The way I selected my chain, longest chain, when they are equivalent, both are 7, 7, the one which gives me the more substituent on them as a substituent would be gets a priority. Therefore, in my chain selection, the chain I selected has 4 substituents, 3 methyl groups and 1 propyl group, 4 substituents. If I had chosen this chain, I would have only 1 substituent right there, another substituent here, 2, another substituent right there, which is 3. So I encourage you, it's very fun to just play with different chain lengths of or different branch of naming, and make sure to apply all of the rules that were adopted by IUPAC. To complete our discussion on nomenclature, now we'll see some of cycloalkanes. That means we have in the structure, you have a cyclic main frame of the compound. So one important thing you need to remember in naming cycloalkanes is that always the base would be the cyclic structure. So that means it takes the base or the suffix of that compound name would always involve the cyclic moiety. Here, for example, the end, the suffix should be cyclohexane. Here, cyclohexane. Here you have to say cyclopentane. Here you have to say cyclohexane. So based on that, what you see throughout the ring system would be, for example, this is a substituent at that position. This is a substituent at that position. This and this are the substituents, but the main frame remains the cyclic compound. Now, to name this, for example, you have a one position, a metal group. So usually we don't say one metal cyclohexane. If it is only one, there is no need to say one metal cyclohexane. So this you can just say metal cyclohexane, 6 carbon. So always the base should refer to the cyclic system. So in your naming, the substituents are the ones which are outside of the cyclic moiety. For example, here, this is a substituent. As you say, this kind of substituent is called tert-butyl. If you remember in our previous discussion, a group something like this with 4 carbon is called tert-butyl. Tert-butyl means tertiary butyl, because you have 1, 2, 3, 4 groups, and the substitution is through this carbon. So this carbon is this substituent is called tert-butyl. When we say tert-butyl, it indicates that tertiary butyl. It means tertiary butyl, because if you just look at here, there are 3 carbons around that carbon through which the bonding happens. So the name for this compound would be tert-butyl cyclopentane. Cyclopentane because it is a 5-membered ring. So if it was a 4-member ring, you would say tert-butyl cyclobutane. Here we have 2 substituents on the ring. So now you start numbering the substituents. So you always have to go through the one which gives you the smallest designation of carbon. So on carbon, if you say this is carbon number 1, because they are the same, it doesn't matter which one is carbon number 1. You don't go through carbon 2, 3, 4 and say 1, 5. That's a no. You always go through counterclockwise in this case, because that gives you a 1, 3 rather than a 1, 5. So you always have to go to the lowest number as you go around it. So this is a 1, 3 dimethyl. Remember what we have done before, cyclohexane. A 1, 3, a 1 and a 3 position. This is position 1, carbon number 2, carbon number 3. So the counting should be this way, not the other way, not to your left, because this, if you were to count that way, it would be 1, 2, 3, 4, 5. You cannot say 1, 5. It's rather, you should say 1, 3 dimethyl cyclohexane. In this case, you have 2 metal groups on the same carbon. These are metal groups. So in this case, you have to say 1, 1 dimethyl. cyclohexane. The 1,1 shows you the substituents are on the same carbon. Therefore, it is very important that you say 1,1 dimethyl cyclohexane. All right. So this is a 1,1 because this is on the same carbon. A 1,1. There are two methyl groups. A dimethyl cyclohexane. Okay. Coming to this one, if you just look at this compound, you have substituents at 1 and 4 position. If you just count here, if it is 1 position, let's say this is 1 position, 2, 3, 4. In this case, whether you go that way or this way, they are the same. But if there is a substituent, that would change which way you should go. So if you are just naming this compound, you have a here, the substituent is right here. How many carbons do you see as a substituent? It's a normal butyl substituent. So it's butyl. It's normal, it's not branched. 1, 2, 3, 4. So at 1 position you have butyl. Alphabetically it's also good that it's B, but at 4 position 1 butyl, 4 methyl cyclohexane. Cyclohexane because 6-member ring. Remember, you are naming it from the most carbon chain takes precedent, and as well as alphabetically when you write it out, you start with 1 butyl, 4 methyl cyclohexane. All right, so those are 2 substituents. In addition to that, if we just look at this now, we have substituents at 1 and 2 position. This is carbon number 1. This is carbon number 2. So based on the number of carbons, I would say the 1 position would be the more carbon you have. This is 1 and this is 2 because you have a substituent with 3 carbon. Here a substituent with 4 carbon. So the substituents are at position 1 and 2. So how do you name this? If you remember from our last discussion on substituents, at 1 position you have sec-butyl. It is a secondary butyl. Sec-butyl because this carbon is attached to 2 carbons. We call that sec-butyl. So a secondary butyl, sec-butyl, at 1 position, 1 sec-butyl, sec is to say a secondary butyl, a branched butyl. It's not a straight chain like this one. We call it sec-butyl. And at 4 position, you have a propyl group because you have 3 carbon, but that propyl is not attached directly through this carbon or through that carbon. It's a branched one. We call that isopropyl. If you remember, this kind of branching is called isopropyl. So now you should remember this is tertiary butyl, this is isopropyl. This group is tert-butyl, this group is isopropyl. So what you see here as a substituent is isopropyl. So this is called isopropyl cyclohexane, 6-membered. Always the suffix or the compound's base name would be the ring system. The ring system cannot be a substituent. So remember to review again and practice more on the nomenclature, both in the just chain compounds, alkyl chains, and also the cycloalkanes. So remember to follow the IUPAC recommendations or conventions how to name organic compounds. With this, we conclude the nomenclature of alkanes and cycloalkanes.